make sure you guys are reducing those fractions every time you set up a ratio or looking for an exact value, okay? All right, so that's sine, cosine, and tangent. So now tangent specifically, opposite over adjacent, right? So the side across over the side that's right next to it. So 8/6. And then simplify that or reduce it, okay? So now down here, now we go into the next step, find a missing side or find a missing angle, okay? So we use that idea of the ratio to help us find that. So usually we have an angle. If we're looking for a side, we have an angle, right? And then we need at least one other side to find that missing side. Okay, so in this case, we're looking for the hypotenuse. But look what we have. Now, first of all, look where the angle is, right? The angle is at the top. And this side right here, is that across from it, opposite, or adjacent to it? It's right next to it, adjacent. So if it's adjacent and I have and I'm looking for the hypotenuse, you have to go back here and say, okay, which of these functions has an adjacent side or includes an adjacent and hypotenuse? And that's the cosine. So that's why, good morning. That's why we chose cosine. So you have to decide which one to use, okay, based on what you have, okay? So same thing here with the sine. This time we're looking for the angle, and we need at least two sides to find an angle. The side that's across from that angle, we have that, opposite, and then we have the hypotenuse. So again, I go back here and say, okay, which of these has an opposite and hypotenuse? Well, it's sine. So that's the one I use to find it, okay? Now, as you get kind of a little bit more complex with these problems, you start running into, first of all, opposite functions, okay? Or where we basically have a, like sine, cosine, and tangent have a brother, or like kind of a cousin function, where sine is the cousin of cosecant, cosine is the cousin of secant, and then tangent has a cousin called cotangent. All they are is the same thing flipped. It's the exact same thing flipped. So here's that same triangle from the other side. It just repeated the whole thing. So here's those ratios we came up with. Cosecant, which is the opposite of sine, is literally flipped. You see how it's 3/5, and then we just flipped it. Now it's 5/3. Okay, or cosine was 4/5, so now it's 5/4. So you literally just think, okay, what's the opposite? And then flip it. Okay, when you're looking for those ratios. Okay. And then there are some steps that do involve radicals. Okay. Or missing sides. Let's say I'm looking for the secant. Okay, so when I'm thinking secant, now I'm going to show you guys some examples. I'm just kind of running through some things. When I'm thinking secant, okay, first of all, that's the cousin to cosine. Cosine, I need the adjacent and the hypotenuse, and secant is the same thing flipped. So I have to go back to my triangle and say, do I have all of that? In this case, I don't. I have the adjacent side right here, but I don't have the hypotenuse. So in some cases, I'm going to have to use Pythagorean theorem to find the missing side first. And then I'll set up the ratio and simplify and all that stuff, okay? All right, so that's what I'm going to go over here in a second. So I kind of just threw it all at you. So now let's go over some examples first, okay? And again, I'm always referring back to this. Always refer back to these notes. And again, this is from the Ed puzzle. So you guys don't have to copy these down because you guys are going to watch the Ed puzzle and get these exact same notes, okay? All right, if anything, you're going to copy down the examples I'm about to do on the board. All right, so let me flip over my mic and here. Okay, so first I'm just going to start off with one triangle. Make sure you can see me. Okay, good. All right, and we have the sides of this triangle. It's 20, 25, and over here is 15. And then this little symbol, which represents the angle, the other name for that is called theta. If you guys kind of ringing a bell, they're going to be turn that up the screen so it's not fuzzy and weird. So that again, just it's like a Greek word, theta, just means angle. Okay, math. All right, so what we want to do is take this triangle and find all 6 trig functions. We're going to find all 6. Okay, so first we're going to start with sine of theta, cosine of theta, or the angle, and tangent of theta. Okay. So I'm looking at again, I'm referring to this. So sine is opposite over hypotenuse. So cosine is adjacent over hypotenuse. Cos, and then toa, tangent, opposite over adjacent. Okay, so that's what I'm referring to. And then when I do the other functions, I'm just going to flip them. Okay. Okay. So sine. Again, that's going to be opposite over hypotenuse. What is the opposite side?
15.
Was it?
15.
Not 15. There's theta.
20, not 20.
Right. Across this way, straight across. Right. That's opposite. So 20 over hypotenuse, which is
25.
and then reduce that, that becomes
4
over 5. Okay. So make sure you always reduce it. All right. Now cosine adjacent over hypotenuse. That's kind of messy. I'm not going to put that over there. Okay, so the adjacent side over the hypotenuse. So adjacent over what? What over what?
15 over 10 divided by 5.
Okay, good. Same hypotenuse. Reduce it.
3 over 5.
3 over 5. Okay. All right. Easy thing about this one, they're all multiples of 5. So you can just divide by 5 and all of them. Okay, tangent. It's what over what? Toa. Opposite over adjacent. So that'd be
25.
20 opposite over
20 over 15.
right, opposite over adjacent, side right next to it. Divide those both by 5, and we get
5 over 3. No, 4 over 3.
4 over 3. All right. Now we do the opposites. The opposite functions, reciprocal functions, because when you flip something, it's called a reciprocal. Okay. So now, when they first came up with this, I was like, why did you guys choose it this way? If I had it my way, I would say that the opposite of sine is secant, and the opposite of this one is cosecant, right? Because like S and C, that makes sense. But somebody wanted to, you know, mess things around and go like, okay, we'll do cosecant, which whatever, okay, is the reciprocal or opposite of that. And all I do is instead of opposite over hypotenuse, it's hypotenuse over opposite. So then the ratio is what?
5 over 4.
Right, you just flip it. And then same thing here, it's secant. Okay, so what would that one be? 3. And last one, cotangent. Cotangent, so that one would be
3 over 4.
4. All right. So once you have like these functions, like the kind of the base ones, sine, cosine, tangent, then it makes it easier to find the others because you just flip it around. Okay. Make sure you guys can see that online. Pan over it just a little bit so it's not running up. There we go.
Okay, so again, that's just if you are looking for the ratios. All right. Let's go to over there and over just a little bit. All right, that's good. Okay, so now let's take a triangle. Let's do what do I want here? And that one looks okay. How about that one? Yeah, let's do that one. Okay, so now let's do this one. Okay, so my triangle's upside down, so you kind of have to like flip things around in your head a little bit. Okay, my theta, my angle is down here. This side is 2, this side is 5. Okay. So right now I'm just going to focus on cosine. All right. Cosine of theta. Okay, cosine, which sides do we need?
Opposite and hypotenuse.
Not opposite. You need adjacent. You need adjacent side and the hypotenuse. Okay, do we have both of those? We're missing which one?
Adjacent.
We're missing this one right here. So with right triangles, if I'm missing a side, what can we use to find that missing side? Pythagorean theorem. So I got to set that up. I got to use Pythagorean theorem basically to find that missing side first. Okay, so which sides are my legs, by the way? What side's going to go on the left side of the equal sign? What's my A and B?
2.
Okay, 2 and what?
5.
2 and C.
2 and
B.
B or A or whatever you want to call it. Because remember that hypotenuse is your C, it goes on the other side. So it goes there. All right, so 2 squared plus A or B, doesn't matter. Okay, goes there. So now we got to solve for B. All right, so now sometimes these numbers are a little bigger and you might not know the square. I mean, if you know it, you know it. So what I'm going to do, I'm just going to do this. Make sure you guys can see that. I can barely see that over there online. That's a little better. Okay. All right, so I'm going to subtract that from both sides, b squared. The reason I'm doing this is because a lot of times I like to just set things up in Desmos and not have to do all the math ahead of time. So here, that last step, what do you got to do to get to simplify b? Don't worry about all those numbers here, but what do I have to do to get b by itself? Square root. So when I set this up online, I'm just going to do that whole thing. Okay. Now, if they're on this side, then it would be that number plus that number, and then I square root the whole thing. If you want, you can simplify each number. You can do 25 and then minus 4 and then do square root. That's fine too. Okay. Now, when I do this, I'm going to end up with a decimal. Okay. So if I end up with a decimal, I have to now simplify it. So I have a choice. All right, because it's going to be 25 minus 4 square root of 21. And I can't reduce that, or not reduce it, but I can't simplify that. Okay, any further. I can't even birthday cake that. Because if I do birthday cake, it's just 3 times 7. There's no group of 2. So that's it. Okay, so now we got that over here. Right? Okay, so now we have adjacent and the opposite. Okay, so now adjacent over hypotenuse. The answer is going to be square root of 21 over 5. Okay, now let's do the cousin of cosine. Same problem. But now, instead of just doing cosine, we're also going to do the secant. The secant is the same thing, but what do we do with that? Flip it. What's the problem with that one? Can't have a square root where?
Denominator.
Denominator. So what do we got to do? Okay, what can we do? What specifically do we do?
Multiply on both sides.
Okay, not both sides, just this side.
Okay.
We did this yesterday. How do we get rid of that square root on the bottom? We're going to multiply something on the top and the bottom. What are we multiplying? Yeah, we square root the same radical. So whatever it is, you multiply it on the top and the bottom. Square root 21, square root 21. Okay. Okay, so now 5 times the square root of 21. Nothing I can do there. So just 5 times the square root of 21. And on the bottom, what do you end up with? 21. All right. So the reason I showed you that is that sometimes you're going to have to rationalize. Okay, that's called rationalize when you get rid of that square root on the bottom of your fraction. Okay, so sometimes I'm going to have to use Pythagorean theorem to find a missing side. Sometimes I'm going to have to rationalize. Okay, that's the moral of the story there. Okay, the last situation you're going to deal with is looking for a missing angle. Looking for missing angles. All right, no, that's fine right there. That way the guys online can take notes stuff. Okay. Okay. Finding missing angles and sides. So let's start with this first. All right, we're just going to do 2 examples here. All right, so we're going to have 63 degrees there, 16 there. I'm going to go ahead and call that 16 feet. Okay. All right, that's x. I got to find x. First thing I got to say to myself, it disappeared. First thing I got to say to myself is, what sides do I have? Because here's my angle right here. Which sides do I have? Do I have the opposite sides? Hypotenuse. Okay, I got the hypotenuse. And what's the other one?
Opposite.
It's opposite. It's a cross. Okay, so if I have the opposite and the hypotenuse, which function am I going to use? Which one is that? Which one has the opposite? Sine. Okay, so sine of an angle is opposite over hypotenuse. So SOH. Okay, so that's what I'm going to use to look for that missing side. Okay, so now I just set it up. Remember, theta is just the angle. So sine of 63. And then it's opposite, which is x over 16. All right. Guys, any thoughts on how to solve that? What do you think? Multiply by what? 16 on
Both sides.
both sides. That cancels out. There's your x. 16 times the sine of 63. Okay. And then just depends on what it's asking for. It might say round to the nearest 10th or round to the nearest 100th. Okay. In this case, when I multiply 16 times 63, which you can do in Desmos, when you do this in Desmos, just type it 16 SIN 63. It'll automatically recognize it. So 14.1 feet. I already have the answer ahead of time. Okay. But I would type that in using Desmos. Your phone also has sine, but you're gonna have to like flip it sideways to get the sine function. Okay. Now, if you do this on your phone, you want to do the sine function first. Do sine of 63, and then hit times 16. Okay, don't do 16 and then times sine. It's going to do it in the wrong order. Okay. Okay, the next one would be, let's say I'm looking for an angle. Let's do, yeah, that's a good one. All right, so let's do another upside down triangle. So this side is going to be 49, let's say meters. This one's 46 meters. I'm sure everybody can see that. Okay. And then we're looking for that angle right there. Okay. Let's put a little arc there. All right, first thing we're going to do. That's our angle. Which sides do I have? 46. What side? What side is that?
Opposite, adjacent,
Opposite and adjacent. What function is that? That's opposite and adjacent. Tangent. The only one I always remember that sine and cosine always have to have hypotenuse. The other one, tangent. Tangent, opposite over adjacent. So set it up just like you did the other one. All right, so now let's see. Tangent of the angle, which I'm just going to call x. Okay, whatever it is, whatever is missing. Okay, or if we had like, let's say these were labeled like A, B, and C, you could just put B there.
we don't call it theta.
You can call it whatever you want. You can call it theta, you can put B, it might be X, just depends on what the problem's giving you. In your packet, let's see what they call it in the packet. In the packet, they call it nothing. Wait, are there any problems in the packet like that? I guess not today. Not till later. Okay, but basically it could be called anything. All right. All right, so sine of that angle, we'll just call it B in this case. All right, so opposite 46 over adjacent 49. All right, now what's different here is we had a missing term or something missing on this side where the ratio was, but now it's in the angle, so we do finish this differently. Do you remember how to do that? It's the angle. What do we do here? What's that? Not times tangent. You're going to do the inverse of tangent. We're going to do the inverse. So you know, like when we find an inverse and we put the little -1. So we use the tangent inverse function. So it looks like that, has a -1. This is also in your calculator. This is also in Desmos. And what you do is you switch these two. So when we do the inverse, we flip that around. And now we're doing the tangent inverse of 46 over 49, or that ratio. And that will give us the angle. Okay. See if I can pull it up. So that's all extra blurry. So when you guys are on here, on the scientific calculator, right here, you guys will see, sorry, you'll see right here right away, sine, cosine, tangent. In order to get the inverse, click on function, and then it'll pop up right there. Okay? So that's how you get to the inverse. So like this one, for instance, I'm going to type tangent inverse of 46 divided by 49, and there it is. Okay, let's say we round to the 10th, 43.2. Okay. B is equal to 43.2. Remember, we're talking about an angle, so put degrees. Okay, so you guys are looking for ratios, you're looking for missing sides and angles, okay? Let's see where we at. Okay, you guys got it, or you guys get it all down. Okay. My microphone. Okay, so in the packet, I want to give you some hints here, some specifics. Okay, so this is 9.2. The first 6 are going to be pretty general, just like there's going to be whole numbers. Some will be the inverse or the reciprocal functions where you have to flip it. The last 4 down here, okay, we'll have some special cases. On number 7, you're going to have to rationalize. Okay, where you have like a square root in the bottom. This one is cotangent, which remember you got to have opposite in the adjacent side, which if you notice we don't. We're missing a side. So if we're missing a side, what do we got to use here first? We have to find the side using what? Right, a squared plus b squared, Pythagorean theorem. So you got to do that first. Find that side. By the way, would this be an AB side or is this C? C, because here's your 90. That's the C. So this will be either A or B. So I'll call it B. All right. On this one, same thing. You're gonna have to find basically on this one and this one. You have to find a missing side first. Okay. Okay. On the back side. And I would have your notes open. I would kind of have this like right next to you as you're going through these, just so that you have kind of that reference after you guys get your notes. And then on the back side of your notes, or if you're able to fit it all on one page, have the opposites. It's cosecant, secant, and cotangent, so you don't get them mixed up. Okay, back page. Okay, so this one, this one's going to involve some rationalizing as well. Rationalize and birthday cake. So simplify the radicals. Okay. Okay, so both of these will have, actually both this one as well. Okay, so that one's also going to have some birthday cake. All right, now this next one, this is kind of some a review on polynomials. Notice what you have in all of these factors. What do we have? All right, they're all squared. So what does that mean all the roots are? What kind of roots are they if they all have squared? They're all double roots. So as you go through this, by the way, how many x-intercepts are there? 3. 1, 2, 3. Okay, and they're all double roots. So if they're all double roots, what are they doing on the graph? They all bounce. That also means it does not cross through the x-axis. It doesn't go through. So it's only going to be on one side. It's either going to be above it or below it. What do you guys think it's going to be? Do you think it's going to be above or below? How do you know? Because of which part? The negative. Yeah.
That negative in front means it's going to be pointing down. All right. So it's pointing down. Okay. Now, what's the degree? What do you guys think the degree is? No, it's not 4. Remember, if they're double roots, they all count as how many? You have 3 x-intercepts, but they're all double roots. So they each count as how many? So 6 total, they each count as 2. That's why it's called a double root. So your degree would be what? 6. Okay. So it's going to cross through, or it's going to touch the x-axis 3 times. So because they're double roots, okay, it's a degree of 6. So if it's a degree of 6, how many turns will it have? So remember, when you count the turns, you increase by 1, so right, 5. All right. Okay, let's see if we can put it together now. All right, so it's pointing down. It has 5 turns, right? So I'm going to start by pointing down. I'm going to go 1, 2, 3, 4, 5. So it ends with itself pointing down. It's going to point down. Now remember, we have 3 x-intercepts, and all 3 of them do what on the graph? They bounce. So if it's pointing down, will it be under the graph, under the x-axis, or above? Under. It'll be like this. So it's all going to bounce at these 3 points. What will this first one be? What number will that be at? Well, before you answer that question, let's figure out what are the roots. Roots are, what's the first one that comes from the x squared? 0. Remember, it's just x, it's just 0. Then minus 2 is? If it's x minus 2? 2. And then x plus 2? Negative 2. Where is it bouncing here? Negative 2. Because think, what's the one the furthest to the left? Where is it bouncing in the middle? 0. And then where is it bouncing on the last one? 2. So now you can put your graph together. Okay. So you guys can, remember it's a sketch, so you can kind of sketch that however you want. Just make sure it's crossing at those points or touching there. All right, guys, this one down here, these are 30, 60, 90. So set up your ratio like we did yesterday. This one is 45, 45, 90. So you can set that up and solve. So remember 1, rad 3, 2, 1, 1, rad 2. Okay, so we went over that in class yesterday. And then we have imaginary. So all this means is that A represents that. So you're doing 2 plus 3i, and then you are adding 1 minus I. Down here, that's going to be the same thing, except instead of adding, we are subtracting. What's important to do on that second one? What do you need to do first? Go ahead. Okay. What's the first step with the letter B? Because in letter A, we can just add up right away. It's just plus. What about this one? Oh, not dividing anything. Well, if I have minus right here in front of the parentheses, what do I have to do first? Distribute it, yeah. Make sure you distribute. That's the difference with that one and the other one. Okay, last one, you are multiplying. So it's basically the same thing each time, except one you're adding, one you're subtracting, and the last one you're multiplying. And how do we multiply that? Or how could we? Yeah, you use the box. So set up your box. Now, when you use the box and we're dealing with I, we need to remember I times I or I squared is equal to what? What is it? -1. Which box is going to have I squared in it? The one on the bottom right. Because we have I times I. Okay. All right, you guys at home, that's it. See y'all mañana. I'm gonna stop recording. If you guys need help, you can stick around.